Hey everyone, hope you guys are doing well. So, in the previous video or the last episode, we implemented this microservices based application and we discussed this whole application and also write the bare minimum CI pipeline for this application. So, to write the CI pipeline, we used GitHub Action, and what we did was whenever we had any push to this repository on the main branch or the master branch, we build that image or we build the image for that particular microservice which has changed and then push that image to Docker Hub. So that was what we did in the last episode. So we had only this particular job, which was build and push, which was building the image and pushing the image to Docker Hub. So that was the bare minimum CI pipeline, but this is something which is not good enough. We need to have a few more jobs for this to be a fully functional CI pipeline, so that we could connect this with our Kubernetes cluster and connect this with ArgoCD, so that we could have a continuous integration and continuous delivery pipeline. So uh, today what we have done is we have added another pipeline that is update manifest job. So this particular job, what it does is whenever we push any changes to this particular repo, it will build and push the image, and after building and pushing the image to Docker Hub, it updates the manifest file. So before this particular job, what we have to do is we have to include all the manifest file for our applications in this repository. So in the last episode we had this Docker file and we deployed this whole microservices based application in locally using this Docker Compose, but this is only for local deployment. If you want to deploy it in Kubernetes cluster, you have to write the Kubernetes manifest file for all of these microservices, right? So first thing first, we had three databases. So for the sake of brevity, what I have done is I have deployed three deployments, one for MongoDB, one for Postgres, which was this one. It is Postgres 15, that's the image which it is using, and then one for MySQL 8.0. So three deployments for three databases, and we are exposing them on their respective ports using cluster IP and using the service with cluster IP. So in production grade systems, generally we don't use deployments, we don't use stateful sets for databases as well. We prefer to use managed services like RDS or MongoDB or any other managed service, because managing databases or stateful application in any Kubernetes cluster as a Kubernetes object is a really difficult task and something which is not reliable. So for that reason we prefer using stateful sets, or we prefer using managed services. But for this video I have decided to go with deployment, and this will get the job done for us. Okay, and then we created the deployment for contact support team microservice, and then we specified the image, and then we created a service so that we could expose this deployment within the cluster. Same goes for e-commerce UI. So we have this image, then environment variable just we have specified in the Docker Compose file here. Similar to that, we're just doing the exact same thing but in the Kubernetes manifest, and then we are exposing this on port 4000 within the cluster. Then similarly we have order management deployment, and then we have a service for it, product catalog deployment, and then we have the service for it, then product inventory deployment, this is the image, and then we have a service for it, then profile management or the auth management microservice. This is the image, and then this is the microservice for it, and then we have the shipping and handling microservice, and this is the deployment for it, and this is the service. So this is how we wrote all the Kubernetes manifest. And what this job does is, let's suppose we made some changes to the e-commerce UI microservice, right? So what it will do is, in the first step, in the build and push job, it builds only the e-commerce UI microservice using let me scroll down, where is it? These are the steps, right? So using this filter, it only builds the microservice which has changed, and then push that microservice image to Docker Hub, right? And then what it does is, it gives us here in the outputs the if the microservice has changed, it will produce in the output as true for that microservice, and if it has not changed, then it will give the value as false for that particular microservice. So let's suppose that we made some changes to the e-commerce UI, and then this particular pipeline files job files, and it produces in the output that e-commerce UI is true in the output, right? So now after this job will trigger, and this job update manifest depends on this build and push job. As you can see, it has this need, and in front of this need it has build and push. That means this job needs this particular job to be successful. If this job fails, this particular job will never trigger, right? And then what it will do is, it will update. I'm sick of this IntelliSense, it is just making life hell. It will using that, gosh, not sure how to stop these IntelliSense. So using the output of the previous step, needs.build and push.outputs.ecommerce UI, if that is true, then what it will do is, it will make it update that particular manifest, this manifest, and change the image to the image that we have just built and pushed to Docker Hub. And same goes for all the other microservices, and then it makes a commit to this particular repository, because it has made the changes to the manifest file, right, in these manifests, so it has to make a commit as well. And then we have the CI pipeline completes. We have build the image, we have pushed the image, and we have updated the manifest files. So with this, our CI pipeline is now ready. And if we configure this repository with ArgoCD, we should have a complete CICD pipeline. So what I'm gonna do is, let's close this one. I have this folder here called cluster. In this cluster we have all these shell scripts needed to create an EKS cluster, and then set up the application load balancer controller, and then we also need the CSI driver as well. So I'm going to create a Kubernetes cluster, because to perform this CI/CD whole pipeline, we need to have the cluster, right? So let's set up the cluster. So what I'm going to do is cd into the cluster folder. Why is it not working? CL cluster, and then first of all I'm going to execute the create EKS script. So this is the script. What it will do is, it will create an EKS cluster with 3 nodes, and the type of the node is T3 medium, in the US East 1 region. So let's execute this one. Create bash, create eks.sh. It will take some time and it will provision the EKS cluster for us, right? So let's pause the video till it completes this creation of cluster. So we have the cluster now ready, so we can do kubectl get nodes. As you can see, we have the cluster ready, but we have to install the CSI driver and then the ALB controller as well. So I'm gonna execute those scripts as well. Setup ALB. It will take some time, and we'll probably say okay. So let's execute let's install the CSI driver as well. Setup CSI driver. So this one is for creation of cluster, this one is to set up the application load balancer controller, this one is to install the CSI driver. So it's taking some time, hopefully it should complete in some time. So our cluster is now ready. We have all the prerequisites. Our cluster is up and running. We have the CSI driver, we have the application load balancer controller installed. So now it's time to actually install the ArgoCD. So I have provided all the commands in the README file. You can copy and just apply those as is. So first it will create the ArgoCD namespace, and then in that namespace it will install the ArgoCD. So let's copy it. It's taking some time. So we have installed ArgoCD. So let's confirm this. kubectl get svc -n ArgoCD. It's not sv, it's svc. Okay, so you can see that the ArgoCD is installed, and these are some of the services. And what we need to do is actually, which one is the ArgoCD? I believe it is which one? Probably, if I'm not mistaken, it is this one, ArgoCD server. This one. So we're gonna change this from cluster IP to load balancer so that we could access it using the load balancer. So I'm gonna copy this command and paste it here. We could have used the port forwarding method as well, but I'm gonna use the cloud provider's load balancer. So let's run this command again. This time we should get the load balancer URL, as you can see. So this is the URL. Just copy it, Control Shift C, and then let's try to paste it here. It will take some time for the load balancer to load properly. In the meanwhile, what I'll do is I'll try to get the credentials of the ArgoCD, which is this command. If you paste this command, let's clear this, it will give you the password, and this password is actually base64 encoded, so we have to decode it. So that is why we have it base64 HT. So this is the password. I'm gonna copy this and let's refresh this. It will take some time, but it should come anytime soon. So now we have the ArgoCD up and running. So let's log into it. So the username, default username is admin, and the password is the one which we have just copied. Paste it here. Let's do the sign in, and now we are in the ArgoCD dashboard. So we can create now our first application. So the application name is, what we do is e-commerce. That is our first application, right? e-commerce. Project name, let's go with default. Sync policies automatic, and then let's keep everything as a auto create the cluster. Apply out of sync only, that's also something which we want to do. And then let's keep everything as is. So GitHub repository, actually we have to create it here first. So we have to go here and add a GitHub repository, and then connect with our first repository, and the URL via HTTP. Type is git, name is e-commerce, project is default, URL is, let's copy it from here. It is the main branch. I think we can copy it from here if I'm not mistaken, and let's paste it here. This is the username, passwords are optional. This is also optional, we don't need this because our repository is private, is public. And let's go with this. I think it should work. Connect. So the connection is successful. That means now we are connected to our GitHub repository. So let's go back to this application tab and then click on new app. Application name is e-commerce, project is default, sync is automatic, and then create autoclave namespaces and apply out of sync only. Repository is this which we have just created. Branch is, yeah, head is good. Path, so the path basically is the manifest. So let's push everything here. cd git add commit -m edit ArgoCD edit CICD full CICD git push. Okay, what is it which is stopping it from fast forward? Failed to push some. Okay, interesting. This actually happened by other. No way. How is that possible? Git add, git commit, git push. Git add, git commit, git push. This usually happens by another. Okay, I'll fix this. In the meanwhile, let's come here, and the path is basically paths to this folder, paths to this particular folder in which our manifest files are present, right? So the path is manifest. That's all we have to give. And then cluster URL, that's not needed, and this is the one. Namespace is, we can give ECOWRC. that's the namespace, nothing else need to be created, and let's hit this create button. So let's refresh our GitHub repository, go back to the main branch, refresh it, as you can see, and then let's check it. It is syncing with our GitHub repository, and it will deploy the application in our Kubernetes cluster. So let's see. Okay, it has detected all the manifest files in our repository, and it is deploying all of them in our cluster. So as you can see that this one is running, this one is running, this one is also running, creating container. So it will take some time. This one is the one which usually takes the most time, even when we were running locally. So we have everything running in our cluster, so let's confirm it from here. kubectl get pods -n. The namespace in which we have deployed our application is e-commerce one, right? So let's do ECOWMERC. As you can see, all the pods are running. So let's get the services, SVC. As you can see, where is it? All the services are also running. So this one is the service which is of our e-commerce UI. So I'm going to port forward it so that we could access it from the browser. So kubectl forward svc / which one, e-commerce UI -n e-commerce on port 4000 on port 4000. Let's hit this, and it should forward this, and we should be able to access it in the browser. So let's try to access it in the browser. Localhost 4000. As you can see, now we are connected to this. Let's create a new account. Let's sign in. Okay, so now we are connected to our application, which is deployed in the Kubernetes cluster. As you can see, everything is working properly. So the interesting thing is, what I'm going to do is, and you can see that this is the title, right? Welcome to the my e-commerce. So here is this thing which is kind of wrong. So I'm going to remove it. So I'll go to the repository. I could have made the commit from my terminal, so I'm having some issues with my terminal, so it is not working. So what I'll do is, I'll go to GitHub directly, and then from here I'll make that change. So in the clients, src pages, home page, and then what I'm gonna do is, I'll remove the let's edit this, remove this, the welcome to the number 1 e-commerce app in the world. Let's commit this, update it. Okay, update header text of the home page, that's right. Let's do the commit. What it will do is, it will trigger the pipeline again if we go to the Actions tab, as you can see, it has triggered this pipeline. Let's click this. Gosh, it's taking some time. I'm having some slow connection. Okay, so it is building the image, and once it's done with the build, it will push the image to Docker Hub, and then it will update the manifest file for the e-commerce UI. And once that is done, if we come here and let's go back, currently it says in synced, but once it is done with this pipeline, execution of this pipeline, if you come here, this will start to redeploy our application, because the e-commerce UI, especially the e-commerce UI microservices, because the manifest file for that service has changed in the repository, in the GitHub repository, and it has to do the syncing again. So it is building the e-commerce UI, as you can see, taking some time because the build process is a little bit heavy, as there are multiple applications, and also we are running on the free GitHub runners, so which is why it does take some time. If we run this on custom instances or runners, this process will be much faster. Okay, so it's pulling, it has pushed the image. Now it is running the update Kubernetes manifest job, and now it's done with this. So now if you come here, it should do the syncing again. In the meanwhile, if we check our code here, we should see a commit here, which has, this is the commit which the GitHub action has just made, and in this commit it has changed the manifest folder, right? So let's come here, and it should start deploying the e-commerce UI anytime soon. Let's wait for some time. Okay, successfully synced few minutes ago. So it says that it has picked up the latest changes, and it has synced the latest changes. So if we refresh this application, okay, so I think it has loaded. So we have to do the port forwarding again, because the service got disconnected because of the port being restarted. So we have to do the port forwarding again. Now if we refresh, we should see the latest, the new tile which we just added. So with this, our CICD pipeline is complete, and this is how we implement a production grade CICD pipeline using GitHub Action in ArgoCD.